everyone, and welcome to Troubleshooting Kubernetes with Confidence. My name is Amy Palua, and I am an LFX mentee focused specifically on increasing awareness around Traceloop. Traceloop is a powerful debugging tool within the Inspektor Gadget ecosystem. Through my mentorship program, I have been conducting deep research into Traceloop's capabilities and positioning in the observability landscape. This research has revealed just how transformative this tool can be for Kubernetes troubleshooting, and I'm passionate about helping platform teams and SREs discover how Traceloop can help enhance their debugging workflows. Today's webinar is all about understanding Traceloop and showing you exactly how it can solve real-world Kubernetes debugging challenges. We'll explore when to use Traceloop versus other tools, see it in action through live demos, and discuss practical strategies for integrating it into your workflows. So I'm excited to be joined today by Alban, who is not only a renowned eBPF expert, but also the pioneer of Inspektor Gadget. So Alban, would you like to introduce yourself and share a bit about your background?
Yes, thank you, Amy. So the first time I got into eBPF was in 2016. And at the time, I was preparing a demo for a talk at KubeCon. It was in London. And the demo was about testing web application in Kubernetes with scope. And the demo was using traffic control to simulate bad network scenarios, for example, to add network latency, or to drop some packets, or to reduce the bandwidth. So it's already related to eBPF. And at the time, I was working at Kinfolk as a co-founder, and we were doing consulting on software development for things that are at the intersection between cloud-native things like Kubernetes and low-level programming like container runtime or systemd or Linux kernel. And after this demo, we at Kinfolk, we had our first contract to work on eBPF, and that was in the context of Kubernetes clusters. So I was excited to go in that direction to do eBPF work. Then we got into this space more, and we got more contracts in the domain. And then I started the project Traceloop and Inspektor Gadget later in 2019. At the beginning, Inspektor Gadget was a collection of eBPF tools for Kubernetes, and Traceloop was the first of those tools. This work was part of Kinfolk Labs at Kinfolk. And later on, in 2021, Kinfolk was acquired by Microsoft. And I have continued to do my work on Inspektor Gadget, including Traceloop, and other eBPF projects as a Microsoft employee.
All right, then. Thank you so much, Alban, for that introduction. So before we dive into your journey and the origin story of Inspektor Gadget, I think it's really valuable for our audience to first understand what Inspektor Gadget is. So through my research into Inspektor Gadget, my understanding is that it fundamentally simplifies debugging, monitoring, and security for Kubernetes operators through familiar kubectl commands and programmatic implementation. What's your take on this perspective, and how would you describe Inspektor Gadget to someone who has never heard of it before?
Yes, you gave a good description. I will say Inspektor Gadget is two things. First is a collection of tools using eBPF for observability, and we call those gadgets, tools gadgets. And second, Inspektor Gadget is a framework for running the gadgets. So today we have 31 official gadgets that have been developed by the Inspektor Gadget development team. But not all those gadgets are official. If you go to Artifact Hub, you will see there are about 40 gadgets. Some of them have been published by third parties, not by the Inspektor Gadget team. In general, that's something we would like to see develop. And it's a bit similar to Docker. With Docker, you can run containers, build containers, push and pull containers using OCI registries like the Docker Hub. And with Inspektor Gadget, you can run gadgets, build gadgets, push and pull gadgets using OCI registries as well. And of course, people can build Docker containers without being part of the Docker development team. And it's the same thing for Inspektor Gadget. We want people to be able to build gadgets on their own and publish them or not on OCI registries on Artifact Hub as well. The second thing I wanted to clarify is Inspektor Gadget and Traceloop are not only about Kubernetes. It works on Linux host as well. Or it works on containers like Docker containers without Kubernetes. Of course, it works well, very well with containers and Kubernetes because the framework in Inspektor Gadget offers features like container arrangement and container filtering, but it doesn't have to be. You don't have to use containers at all. And finally, Inspektor Gadget aims to be used in a variety of contexts. You can run a gadget with Inspektor Gadget, and the gadget can output some events in a varieties of ways. For example, you can output in a column view in the terminal window, or in JSON, or in YAML, but it can either be queried remotely using gRPC. That part is used by the kubectl gadget client or the headlamp Kubernetes UI. They are using gRPC internally. And we have other exporters as well for logs, for example, using OpenTelemetry, or for metrics using Prometheus. And we also support other protocols like the OpenTelemetry protocol using gRPC. There are also some external projects using Inspektor Gadget, using it with a Go library, and so they consume the event directly in their process.
All right, then. Thank you so much, Alban, for the very extensive explanation. This is actually a great foundation. So now that our audience understands what Inspektor Gadget is and its core value proposition, I would love to hear the story behind it. Like, let's start with your journey. How did Inspektor Gadget come to be? What problem were you trying to solve that led to its creation?
Yes. So the Inspektor Gadget story started in 2019. At the time, we were at Infog, and we had worked on a few eBPF projects for customers, but there was no good integration with Kubernetes. Whenever we needed to learn something about eBPF, we used the BCC project, the BPF compiler collections, which are collections of eBPF tools, and that was a great resource. But all those tools from BCC, they are designed to be run on the command line on the single Linux host. So that's a different context than Kubernetes. And that was difficult to run them on Kubernetes because Kubernetes users, they don't normally use SSH to connect to a worker node or to connect to a pod and install BCC there. That's not how it works. And BCC tools although don't have any container integrations. So at the beginning of the Inspektor Gadget project, initially, some of the gadgets, they were just BCC tools repackaged, and so that they can run inside a Kubernetes pod. And initially, kubectl gadget was just a shell script wrapping the kubectl exec command to execute some BCC tools in a Kubernetes pod. So the gadgets were running inside the Inspektor Gadget pod in that way. Today, it's quite different. The Inspektor Gadget quite evolved, and the gadgets are not based on BCC anymore. And we no longer have any built-in gadgets. All the gadgets are OCI image on OCI registries. And although all gadgets use BTF, BTF stands for eBPF type format. And what it allows us to do is to run BPF programs, compile them one time and then run them many times on many different kernels.
All right, then. Thank you. So since eBPF is really the engine, from like all you said, I kind of understand that since it's really the engine that makes all of this possible, like let's make sure everyone understands this foundational technology. So Alban, you're recognized as a leading eBPF expert. So before we dive into Traceloop specifically, I think it's crucial for our audience to understand this foundation. So for those who might be new to eBPF, can you give us a concise overview of like how eBPF works and why it's revolutionary for observability, and perhaps touch on why eBPF was the right choice for powering Inspektor Gadget's capabilities?
Yes, sure. So eBPF program is just a piece of code executed by the Linux kernel in the kernel context. and it can be configured to be triggered by specific events. For example, it can be executed, it can be attached on a network to be executed for each network packet on a network, or it could be attached on trace points, for example, to be executed for each system call, or it could be attached to any almost any function in the Linux kernel. Additionally, eBPF program is running in a sandbox environment. So even if it is running in a kernel context, it is actually safe to run. It will not crash the kernel, it will not loop indefinitely, and it will not write in random kernel memory in unexpected ways. So to ensure that, there is a key component called the eBPF verifier, and that component will make sure that the eBPF program is safe to run. In general, eBPF is not a new technology. It stands for Berkeley Packet Filter. And initially, it was for filtering network packets to improve the performance of TCP dump on similar tools like Wireshark. That was in the early 90s. But since then, eBPF stands for Extended BPF. It changed a lot, and it's not only about TCP dump anymore. But the key idea to improve the performance, it remained the same. So maybe I can give an example, and I will try to show that on Excalibur. Let me find if I can share my screen. Okay, yeah, can you see my screen?
Yes, I can.
Okay, so that's just a diagram of the TCP dump process that wants to get all the packets with port 80, TCP port 80. To do that, it needs to ask the kernel to capture all the packets from the network. And then the packets are copied to be given to TCP dump. And if BPF didn't exist, then the way to do that will be to have TCP dump to look at the packet. If the port is not what is requested, then it discard it, and otherwise print it to the user. But doing this way is not really efficient because it needs to copy all the packets from the network. And if there is a lot of network traffic, that's a lot of things to do, a lot of memory copy, and a lot of context switch to the TCP dump process. To avoid that, what we do with eBPF or with BPF in general, the filter is done in BPF in the kernel. So let's take the filter away, and it will be done here in the kernel. So instead of always copying the packet and racking up the TCP dump process, if the port is not 80, it will just discard the packet here, and it will not be copied. And then the TCP dump process will not be woken up, and it will not notice anything. So there will be no performance impact. Okay, that was for the explanation about
Thank you.
TCP dump. Okay, but if eBPF didn't exist in general or outside, I'm not talking about TCP dump anymore. The innovation in observability tools, it will be at a much lower speed. Let's say, I will take another example. Let's say you are a company that wants to offer new observability tools for your customers. So you write the tool to observe specific, for example, specific something in a Linux file system. You want to observe specific files. And of course, Linux already has some API for that, like the iNotify API or the FunNotify API. But if you want to get additional information that is available in Linux, but is not provided by the existing API, then you have a few choices for your implementation. The first one will be to contribute some patch to the Linux kernel, so it benefits from everyone. But it can take some time for the patch to be reviewed, accepted in Linux, and released in the new versions. And even when the new version of Linux is released, it can take years for your customers to be able to use that Linux version. Especially because often your customers don't want to modify the kernel. They want to rely on a kernel that is provided by the Linux distribution, and maybe they use a LTS Linux distribution. And for example, Ubuntu LTS version are released every 2 years, but the cycle can be longer than that. For example, Red Hat Enterprise Linux has maintenance support for 10 years, and it can be sometimes extended to 14 years. Of course, no startup can wait for that long to bring their product to market. So that's not good enough. Another solution will be to write a kernel module that you can ship with your observability tool. That was the solution chosen by SysDig before they used eBPF, before eBPF was good enough for this. But writing kernel modules has several drawbacks. First, if you have any bugs in the kernel module, it can crash the kernel or it can cause security issues. So your customers are going to be reluctant to use that. It can also impact the commercial support they get from the Linux distribution. And it impacts security features like secure boot as well. And it's not so practical because a kernel module has to be recompiled for a specific kernel. So if you need to support a lot of Linux distribution on a lot of kernel versions, that's going to be painful. Even if you use a tool like DKMS to recompile a kernel module on demand automatically, that's not so ideal. But with eBPF, you don't have all those problems. You can write a eBPF program one time and be attached to a specific kernel version or some other subsystem in Linux. And then it is immediately, it can be deployed immediately on existing kernels safely. And that's why it's revolutionary, and that's why it's a right choice for Inspektor Gadget as well. Yeah, to summarize about eBPF, it offers a great visibility by being able to hook in almost any function in Linux. It is performance thanks to the compilation to native code and to the way it can filter events and the way it communicates with user space processes. And it is safe thanks to the sandboxing and the eBPF verifier. And although, as I mentioned, the path from development to deployment in production is very quick.
All right, then. Thank you so much, Alban. You just broke this down so much that I kind of understand eBPF a little bit more now. So thank you. So now that I've been learning about and evaluating Traceloop alongside other observability tools like SREs, Prometheus, and even traditional logging, I have discovered like some interesting trade-offs between like short-running diagnostic tools versus long-running monitoring solutions. So where does Traceloop fit in this spectrum, and what gaps does it fill that other tools don't?
Yes, that's a great question. I will say there are two ways to use observability tools. The first one, long-term observability or always-on observability. This is meant to be enabled in production system permanently. This can include logging, metrics, or distributed tracing. And for those categories, it needs to be done in a sufficiently low overhead. That means it should not be using too much CPU or too much memory, or too much disk space or network bandwidth, because it's enabled permanently in production. So we should not have this performance impact. And this puts constraints in what you can do and how you do it. For example, for logs, we cannot log every single request or every single system call. That's not possible. So for logs, we only normally capture only significant events or errors or warnings on key steps, but not everything. And it's similar with metrics and Prometheus. You cannot do everything. Metrics, they are fundamentally about event aggregation, counting how many events of a specific kind happen. And we cannot attach too much information on a single event for Prometheus metrics. And specifically, we cannot use labels with a high cardinality, such as email address or file path, because that would be too many metrics to count. And finally, I mentioned distributed tracing with OpenTelemetry. With that, you usually have a way to sample the trace you keep to avoid storing 100% of the traces. And there are different methods on OpenTelemetry to do that, to sample the traces. There are what is called head-based sampling or tail-based sampling. So in all of that, you need to restrict what you can do. And then there is a second category of observability tools. Instead of long-term observability, I will call them on-demand observability. They're often interactive. And there are many tools like SREs for tracing system calls, pprof for Go application to look at the memory profile or CPU profile, debuggers like GDB, TCP-dump, and many others. And those tools, it's often on demand, they are used on demand, and they are not often not meant to be used permanently because of the performance impact. Tools based on eBPF, they can be of either categories. It depends what you do, what is being observed on the context. And in Inspektor Gadget, we have gadget, some of them that are more used for always-on observability. For example, trace exec and trace DNS gadgets. Some external project like kubectl, it's a Kubernetes security platform. It uses trace exec and trace DNS gadgets. And then we have other gadgets in Inspektor Gadget that are more used interactively. For example, the second advisor. So where does Traceloop fit in that? I will say it's a bit of both. On one side, the eBPF program is tracing all system calls in a permanent way. It traces all the system calls, including arguments, and it is meant to be always on. But the recording of those events is stored in memory in eBPF maps. Then the Inspektor Gadget process is only fetching those events from the eBPF map on the node in an interactive way. In this way, we have a very little performance penalty most of the time when the user are not requesting that. It's only when the user requests the events that we have a bigger performance penalty because we need to actually copy the events from the eBPF map. The catch with that system is that the eBPF map in memory have a limited size. So we cannot store the events forever in memory. So the oldest event get deleted to make space for new events. So we don't keep everything.
All right, thank you very much, Alban. So you just mentioned something about how it catches eBPF maps and how they have a limited size in memory. So can you talk more about eBPF maps so we can understand better?
Yes, so I will say the choice of eBPF maps, it defines the communication between the eBPF program and the Inspektor Gadget process. And that's a crucial choice for performance. It depends if your gadget is meant to generate a stream of events or generate metrics. Or I will talk about Traceloop, it does it in a different way too. So let me try to go back to Excalibur. I will just give me 1 minute, and I will share my screen again. Need to find the button again. Sorry. Okay. So it's a similar drawing as before. We have the Inspektor Gadget process in user space at the top, and the eBPF program running in the kernel and attached to some hook, for example, trace points or system calls or otherwise. And the communication between the two happens through eBPF maps. And eBPF maps is a data structure, and a data structure of different types. For example, we have array. So array is just many different cells. The first one with index 0, and then index 1, and so on. And then we can store any kind of data between those two. Another data structure for eBPF maps is hash maps. So here we have keys and values. So that's hash map. And hash maps are often used for metrics because you can count how many times specific events, for example, the system call open, And you can put a counter to say it happened at this amount of time. So when the eBPF program run detect the execution of a system call, it will increment the counter here. This. So this is done by writing in the eBPF map. And then Inspektor Gadget, from time to time, it will read the eBPF map to see the counter and export that on Prometheus, for example. Okay. And then you have different kind of maps for streaming events. You will use a ring buffer. And the way it works is different. So in this case, the eBPF program will put an event here, and then a second event, and then another one. So there will be a pointer here saying where it have to write, and then when the next event is returned, the pointer will go there and so on. And then Inspektor Gadget will start to read from the first one. It will take the first packet, the first events, and so on. And then it will take the second one and so on. And when it reaches the end, it will continue producing the next packet at the beginning. So that's most gadgets in Inspektor Gadget use that ring buffer, where there is a producer of events in the ring buffer and the consumer of events. Normally, hopefully, the ring buffer never gets full, because when it's full, then it's no longer possible to write in the ring buffer, and that's how it works. For Traceloop, we use ring buffer as well, but it's configured in a different way. Instead of so let me make some space. So the events will be written at the end, and then we will have a pointer to say where to write next. And when a new event is coming, you move the pointer to know where to put the next event, and so on. And the difference is the ring buffer is configured in an overwritable way, which means that when it's then it's a circular buffer, and then we will overwrite the previous events. So, and during this process, Inspektor Gadget will not read the buffer at all. So there is no communication between the Inspektor Gadget process and the kernel, and it's so it means there is no big performance impact. And it's only when the user requests for it that Inspektor Gadget will start to read everything, and it will read from the from this pointer, and then everything that is available in one go. Of course, the previous buffer that were overwritten are no longer available, so you cannot get everything, but you get the last few events that happen in the system. And that's the basic idea for Traceloop. You have a ring buffer for each container. So each container have you get a record of the last few events that happened there.
All right, then. Thank you so much, Alban. So this has been very granular, and now that we have learned about the nitty-gritty of eBPF and eBPF maps, I wanted to know if you could walk me through like some scenarios where Traceloop would be particularly helpful for our audience. So maybe show us how we complement tools like Prometheus, or when it really shines compared to something else like SREs.
Yes. Well, first, I will say that Traceloop gives you the same information as SREs, so it gives you the system calls and the parameters. The difference is it has it does not have the performance penalty from SREs, because SREs it slows down the application so much that you cannot really use that in production all the time. But Traceloop you can, because most of the time the events are not consumed, so there is no communication between the kernel and Inspektor Gadget, and it's just writing memory, which is quite fast. Yeah, the difference is the catch is when the user actually want to look at the system calls, we don't get everything, but just the last few events, as many as it can fit in memory. Yes, and with Prometheus, there is a difference too. Prometheus, you can only store counters of system calls, for example, how many times you had an open system call, read, write, close, and so on. And you can get it for each Kubernetes deployment if you want. But you will not store all the parameters from all the system calls, like in the open system call, the file name, and so on, because those values are not bounded. They are unbounded, so that would be too much counter to keep for Prometheus. In Traceloop, you can get all that because that's not done in the same way. So in summary, that's a trade-off between performance, granularity, and the Windows time window where you can see the events. With Trace or Prometheus, you see everything in the past, but at Traceloop, you have a small window to see the last few events when you ask for this.
All right then, thank you very much. So I guess right now we can get hands-on and know what exactly is Traceloop, how does it work from other Inspektor Gadget tools, and can you show us a real debugging scenario where Traceloop shines, so our audience can get to know very much what it is and how it can help them?
Yes. Sorry, just one second. My Windows seems to have crashed. Can you hear me?
Oh, wow.
Okay. Sorry, just my computer being slow. Yes, I wanted to show you a few things. I wanted to show you Artifact Hub, how it looks like, and how Inspektor Gadget looks like when it's used from Headlamp, and Inspektor Gadget Desktop too as well, as a UI for Inspektor Gadget. And then a couple of demos using the shell, using Traceloop in the shell. So let me share the window again. Can you see Artifact Hub?
Yes, I can.
Okay, cool. So Artifact Hub is a website from CNCF. And what it does is a dictionary of all the artifacts from several cloud-native projects, including Inspektor Gadget. So Inspektor Gadget, we can publish the gadget in there. So if you search for Traceloop, which is the gadget from Inspektor Gadget, you can see it here. And yeah, otherwise, if I search for other things, I can see, I can filter by gadgets from Inspektor Gadget. And if I want to look all of them, I'll see, sorry, I've moved the filter. Okay, I see there are 40 gadgets reported here. So that's a way to search for what is available here. Most of them are official gadget by the Inspektor Gadget team. So that's what is written by this logo here. But some of them are external third parties or copies. It's like Docker Hub. Anyone can copy, make a fork, copy gadget to our new one. Okay. So let me show you headlamp now. How it looks like in headlamp. I will share the window again. Okay, so headlamp is a Kubernetes UI. It can be both application installed on my laptop here, like it is here, or it could be as a web UI. And it can connect to different Kubernetes clusters. So I can see the namespace and the deployment in that namespace and so on. What is interesting, it has a plugin system. And one of the plugins is Inspektor Gadget. So it means I have this gadget tab here. If I click on it, I can see, well, I don't have any gadgets running at the moment, but I can add a gadget. And what I see here is the list of gadgets it finds from Artifact Hub. So I can see Traceloop here and others as well. It does not have to be on Artifact Hub. If I know the URL of the gadget on an OCA registry, I can type it here. Yeah, so that's one thing. So headlamp is only for Kubernetes, and you can run a gadget from here. And I will show you as well Inspektor Gadget desktop. Second, I will share the window again. Okay, so that's a quite new project. It's part of the Inspektor Gadget development team. So first, as opposed to headlamp, it can connect to both Inspektor Gadget and Kubernetes. But although Inspektor Gadget standalone on, for example, on a single host, single Linux host. Here I already configured the connection to AKS cluster, so it's on Kubernetes. And I can see the previous gadget I've run when I was testing this, and I can type the name of the gadget and execute it, choose the environment. And then I will have to fill the parameters, and then I can execute it. I can also see the gadget gallery, and that's the same thing. It takes the list from Artifact Hub, so I can see everything that is published there. Some of them are official, some not. Okay, but then I will show you from the command line. Actually, Traceloop is not fully supported from Inspektor Gadget desktop or headlamp yet, so that's why I will show you the command line. Okay, so let me share the line. Just 1 second. Can you see my screen?
Yes, I can.
Okay. It seems to have stopped my shell, so I will try to start the new one. Let's see if it is connected. Yes, okay. So what I did, I used this application called OpenTelemetry Demo. It has a bunch of deployment on Kubernetes, and I install it on my Azure Kubernetes cluster. And it's deployed here. And I wanted to show 2 short demos. One is just running a command in a shell. So first I use the kubectl-gadget command. So it's the gadget Inspektor Gadget plugin to the kubectl command, and I will run a gadget, and then I specify the name of the gadget. In this case, I use Traceloop, and that's a version of Traceloop installed in my GitHub repository. So it will pick it from this OCI registry. And then I can specify several parameters if I want to. First, I only care about the default namespace. So that's where I deploy my application here. And I can specify the name of the pod I want to look at. I don't have to specify that if I want to look at everything. I can restrict the set of pods it's looking at, for example, using Kubernetes labels or the name of the pod, and so on. But in this demo, I just want to show you one limited thing, just looking at this pod. And I will look at only some specific system calls to be more concise. And that's about it. And the last parameter is to say which field I want to see. Since I have a kind of demo effect, I have some warning messages. I did not have time to debug this yet, but if you take the releases instead of my fork, that should be better. So now you start to trace all the events. It means there are eBPF maps running installed with ring buffer to collect events, but it doesn't display anything there. It doesn't display anything because it's only on a user request when the user actually asks for it that it copy the events to Inspektor Gadget. So now I will take another shell and generate some of those sessions. So in this new shell, I will start this new pod where I will run a simple command. It's a command that tries to display a file that doesn't exist, so I get an error. But I wanted to show you on the system calls what happened there. First, as you see, there is no events because it's only on user request that Inspektor Gadget will copy the content of the ring buffer. And so now I ask for it, and I get the last few system calls that are requested. So you see the open system call on the file, and then the error message that this file did not exist. And I see under the read write system call as a requested. So that was a short demo to show you the filtering, how you can specify what you want to look at. In general, a lot of those commands like --pod main and so on, they are generic flags. It's not only for Traceloop, but all the gadgets in Inspektor Gadget have this similar filtering system. Only this is specific to Traceloop. Okay, now I want to show you another demo. So it's related to OpenTelemetry demo. I will show you first in this. There is this pod called load generator, and I see there is some errors there. It's a connection refused. So probably try to connect to some remote endpoint, and it didn't work. And in this scenario, let's say this is a error that seldom happens. So if I don't know how to reproduce it, I don't really want to trace all the system calls to see where it tries to connect to with a tool that will collect everything, because that would be too much. But here, that's an example where Traceloop can be really useful, because you can enable the tracing of the system calls, but not keep it permanently in production, not look at it. But when you actually have a specific error, then you can look back and dump the last few system calls to understand what happened. So that's what I will. I will run. I will run the Traceloop again. This time I select my pod using Kubernetes label only for the load generator, and I want to look at those system calls because it seems to be a TCP connection, so this seems like a good fit. And then I will wait until a new line of log with the refuse connection happen. And probably it happened now, so I can stop it and retrieve the log. And I can see all the previous connect system calls and the system call I requested. And I see the error. So here I can see one error with one IPv6 address, for example. So I can go through the different errors and find out what happened there. Okay, so that was to show you how you when you have an error that very rarely happen in production, and you don't necessarily want to have heavy tracing, you can enable Traceloop, record things on the time, and when you say, oh no, a pod crash, or I have a specific error, I want to look in the next in the last few minutes to get the system calls and get there. If I have time, I don't know if I have time, I will show you something with the AI as well.
We have some time left. I think if you could quickly show us this demo, if it could be quick, then we can just do that. And then.
Okay. So that was a demo that was prepared by my colleagues, Kazim. So that's a chatbot. And it showed the integration between this chatbot and Inspektor Gadget on Traceloop. Because you hear my colleague ask, please do a recording of this component of the OpenTelemetry demo application on this, and it will check if Inspektor Gadget is running. It's running, and then it will suggest to run Traceloop with those parameters, and then the chatbot will connect to Inspektor Gadget using a MCP server to run the query, run this command for 30 seconds, get the results, and then the chatbot will be able to analyze that, and you can ask a further question like, okay, what is this? What does this error mean, and so on. Okay. That was a short demo.
Yeah. Yes. All right. Thank you very much, Alban. So you've done like a very in-depth demo on like various on different arms. And I wanted to just ask, like, in those demos that you showed us, what is something that we saw that I couldn't get from like kubectl logs or like describe, or even when I deploy SREs, what is something that was there that I couldn't get from them?
Yes. If you use kubectl logs, you cannot see any system calls because that's only the logs on the system call and dot logs. And if I compare to SREs, what we get in addition to SREs is the performance, because while we get the events, we don't have the same performance impact. And in general, by using the Inspektor Gadget framework, we get container filtering on enrichment. So I didn't show it here, but you can add in the events you get from Traceloop, you can see from which pod it comes from and so on. And you can filter by containers as I showed. And in general, we get the easy distribution of gadgets by OCR registry. So you can write your gadget based on Traceloop and publish it, and then share it on OCR registry and use it.
All right, then. So thank you very much, Alban. So our time is fast spent, so I'll just like breeze through the rest of the questions. So now that we've seen Traceloop in action, from my research, I want to walk everyone through like some specific scenarios where I found it to be particularly transformative for Kubernetes system administrators, DevOps engineers, even open source contributors. So I'll just quickly share just this slide about that. Please let me know if you can see my screen or when. Can you see it?
Not yet, no. It's loading.
Okay.
Yes, I can see it.
Okay, so I'm trying to, for some reason, it's moved away. So I'm trying to get us back there. Just give me a sec, please. Oh, so for some reason, I cannot find it at the moment. So I will just stop sharing and then just speak through it, since I can't find it at the moment. But then I personally think that it can help, like for like maybe a production pod crash. Say the app crashes in production, we can deploy Traceloop and then see exactly what happened before the crash. I also think for like CI/CD integration, you can like, if your test can pass locally but fail in pipeline, Traceloop can help identify the environment differences. And lastly, also like for open source contributors, Traceloop can help you document and fix issues. So which of these use cases resonates with you, with what you're seeing in the field? Like, are there any use cases you think I'm missing, or anybody watching this right now? If there are any ones, please comment below, or if there are any other type of use cases you think Traceloop can help with, please comment below. But Alban, what do you think? Like, what do you think about these use cases that we just spoke about now?
Yeah, I think the three you mentioned are all relevant. I like the one about CI/CD integration. Like, I'm thinking, oh, if we have a test that failed, then the reason it failed is maybe hidden back to the previous system calls. And Traceloop could help to get them, and that might be useful for developers to find out why the test is failing. So I quite like that. In general, for me, I'm a developer, and so I like to test the code outright. So when my code is not working in a specific environment, I find Traceloop and Inspektor Gadget quite practical to use, because it's I don't have to connect to the environment with SSH, use trace, and so on. It's tools that we have the infrastructure to connect and get the events. Yeah, although in the demo I showed before, I was using the kubectl gadget command. So it works because Inspektor Gadget is already installed on a cluster as a daemon set, but it's not the only way to use it. We can use the kubectl debug command, which will deploy Inspektor Gadget just in one pod on the one node you want to debug, and then you can do that without having anything pre-installed before. So I find that flexible as a developer.
Yeah. Okay then, thank you. So just because of time, I just wanted to breeze through the rest of the questions I have. So what makes Traceloop fundamentally different from other Inspektor Gadget tools?
Yes, the fundamentally different thing is the flight recorder ID, because it uses a ring buffer which is overwritable. So it's not like other gadgets that consume the events from the ring buffer as they come, but it's the idea to get it later on user request when we need it to reduce the performance impact. So that's the main thing. Okay,
thank you. So personally, I see tremendous potential for Traceloop, and I'm really curious about partnerships. So are there any opportunities for other observability tools or platforms to integrate with Traceloop?
Yes, I see two things. The first is to support other UI for Traceloop. I'll show you the kubectl gadget command on the shell in the console. But so far we have a headlamp on Inspektor Gadget desktop as a UI or web UI. And today they don't support Traceloop yet, so I would like to have this integration. And the other thing is, so Traceloop is a nice idea for this idea of flight recording, but today it's only about system calls, and there are so many other things that could be traced in the same way, like for example, DNS requests or anything that all the other gadgets do. If we can do it in a Traceloop way where we it's enabled all the times, but we only gather things on user requests, that could be a way to enable more things and use it from time to time.
Okay, so 2 more questions. We have just roughly 2 minutes left. So I'll just quickly breeze through the 2 more questions. So from a strategic perspective, where do you see Traceloop heading? Like, what's the roadmap? Like, just quickly.
Yes, so one thing is polishing and making it easier to use. So bug fixing. And another thing is supporting more system calls, because I'll show you a few like read, write, close, connect, and so on. So those works. Some, they don't details everything, so that could be improved. That's something to put on our roadmap. Integration with Inspektor Gadget desktop on a lamp, I'll talk about it. Yeah, what's required for that is to, the way the lifecycle of Gadget works, we have between the Inspektor Gadget client and the server, we have a request to start a gadget or to stop a gadget and to receive events. But we will need an additional API for Traceloop to be able to request don't stop the gadget, but I just want to look at the buffer for this specific pod, for example. And so we need to add those API to be able to integrate it better in the UI. And once we have that, that will open new use case. For example, to get sampling, like for example, get the buffer every hour, or write specific gadgets, like when there is a specific error on, for example, executing a binary and we get permission denied or something, then get the last events based on this event. So there are a lot of things like that we could do.
All right, so I guess this will be my last question. So for platform teams and then SREs watching this, who want to get involved, whether as users or contributors, what's the best way to engage?
Yes, you can talk to us on Slack, on GitHub, and tell us about your use case and about missing feature that you would like to have. In general, that's how it works for the other gadgets like Trace exec and Trace DNS, that they're most popular right now. And that's how feature get added, because we get feedback on what people want on that. So I think Traceloop can work the same. And otherwise, Traceloop is an open source project, Inspektor Gadget as well. They are part of the CNCF sandbox projects. And we encourage contribution in an open source way. So it could be patches on GitHub, but otherwise, general feedback is useful, because in the development team, we are a team of 10 people, but most of us are more on the software development side, and we have less experience in operation or in SRE. So feedback from people from different experience would be beneficial too.
All right then. So thank you so much, Alban. We are right on time, and I do not want to take more of anyone's time. So thank you so much for coming and then contributing your wealth of knowledge to this webinar. I'm very, very sure that people have gotten so much from this, and I want to thank you for making time to come on here and talk to us. So thank you very much. Have a nice day.
Thank you, Amy.
Yeah,
have a good day too.
Bye, Alban.
Bye.